Yeah, we're getting some of that characteristic blue sky that you often see before tropical weather. And it makes sense because you can't have a whole lot of upward motion across a wide area without compensating downward motion. So there could be a little bit of that happening around here. And we can see that on the Skew-T. This corresponds to the image of the sky that you saw just a few minutes ago. And we do have some very dry layers. One up there about 10 to 15,000, and looks like the upper troposphere also kind of dry. But we are getting that easterly flow starting to set up. I can see that cumulus moving westward. So we are starting to get into some of the periphery of these two storms. And there's our current setup. They've taken Marco off the map. I'm going to go ahead and go to that in just a minute. But Laura has come up to hurricane strength this morning. And yeah, let me get those winds. 75 miles an hour, 990 millibars, kind of high. But that's going to be tumbling here during the day into tonight and moving west-northwest at 14. The last update from Marco came at 4 in the morning there. Let's look at that graphic. And there it is, moving very slowly westward. A lot of the precip field got sheared over and carried to the northeast, and that just left a low-level circulation. And it was 30 miles an hour wind field at last movement, and it's just about gone there. And here we have the 1 p.m. update for Laura, and they're still bringing that track pretty much right towards Beaumont, Port Arthur. There has been concern of that track shifting west. Galveston, mandatory evacuation orders there. It's almost a situation that resembles Rita from 2005 in some ways. What's interesting is that at 6Z, about half of the GFS ensemble members were bringing a track right into Galveston Bay. So there's been some definite concern over the track shifting west. But NHC has done very well with these projections coming close to land. We saw them pretty much nail that westward track of Marco yesterday, even though a lot of the guidance was bringing Marco inland. The GFS 12Z deterministic model did bring the track into Beaumont, so it looks like we're kind of converging on that kind of scenario for tomorrow. All right, let me see what kind of new model data we've gotten. Okay, nothing but updated fixes, so I have nothing new to pass on to you. We should see a bunch of 12Z guidance come in later this hour. So let's check out what's going on around the country. Well, we do have some storms out in the northeast U.S. Severe watch boxes going up for Pennsylvania and eastern Ohio, and an enhanced risk for the Philadelphia and Baltimore area. Of course, in any convective weather situation, we want to know where the storms are and where they've been. So let's roll things back to yesterday. There we see a lot of storm activity across the northeast U.S. It is scattered, and then down to the south we see precipitation bands. Part of it associated with Marco right there, the rest of it just typical summertime stuff in southern Georgia. We run that forward through the evening. A lot of it shuts down, but we do have a fast flow aloft across the southeast, so a lot of it persists after dark. We see a MCS cluster come together in Wisconsin, not too far from Kenosha, where they've had rioting problems last night. And yeah, MCS got together. A lot of rain affecting that area, so I'm sure that helped with the fires. And another brief MCS firing in western New York. And down to the south, precip associated with Marco, still going at it at 5 a.m. Then running forward into this morning, that brings us to the current time there. Still remains of an MCS in southern Lake Michigan, and the remains of Marco across Mississippi and Alabama. And of course, Laura, too far away to be detected by radar, but that should be coming into range around the same time tomorrow. I guess we can start out with our surface map there. There's kind of an MCS across Alabama and the Atlanta area out to Jackson. And as a result, I've got kind of a outflow boundary, an active one, moving north into southern Tennessee. There's the surface remains of Marco there. Very shallow circulation, drifting westward, and that's going to be picked up by the circulation in Laura. Let's look at that. This is the model-derived surface analysis, and we don't even really have a closed circulation down there. Just kind of what looks like a very sharp easterly wave right there south of Louisiana. And if we roll this forward, we go into the 4 p.m. hour, and then 7 p.m., and you see that moving westward as an easterly wave. However, we do have Laura starting to enter the picture down there, and this easterly wave kind of folds into the circulation on the west side. And that brings us to tomorrow. Yep, during the afternoon, we're going to see Laura approaching the coast and then making landfall sometime in the evening. I think right now the most reliable model is going to be the GFS. So looking at that forecast, going right into the Port Arthur area just after midnight. And I don't have a central pressure on that, but it looks like maybe about 950 or so, 950 to 955. And then the European solution. I've not seen the 12Z European model. Yep, looks like that has just come in. And let's see what that's got going. A westward track, slightly westward, but still in the Beaumont-Port Arthur area. And then that moves up into the Jasper, Texas area. Landfall, according to the European model, also after midnight. So I think we've got some fairly decent agreement on the landfall scenario. Okay, so back to our surface analysis. Overall, we're dominated by high pressure. Can't really see it too well, but that's it right there. If I drop the highs in, let me do that. They're going to be running kind of like that right there. So that's going to give us kind of a northeasterly flow or easterly flow along the Gulf Coast as Laura approaches. The satellite loop at this time shows the remnants of Marco moving up into Mississippi and Alabama. The surface circulation located about right there. According to the GFS, as I mentioned, it looks more like an open wave. And then off to the south, we see the approach of Laura. Pretty well developed easterly flow on the Florida coast, but things are pretty shut down. That kind of goes back to that thing I told you about compensating downward motion, and it looks like they do have that downward motion in effect there. In the northeast U.S., we are expecting an active day there. Looks like one storm around the Binghamton area, another northeast of Pittsburgh, and the front pretty much tracing southwest along that convection. So we do know we have moisture out ahead of this frontal system, and we'll check that out on the surface chart. And then up to the north, cold air advection pattern setting in once again, and we've got that opposite lake effect scenario. You know that from November and December, we often see clouds developing on the lakes and giving us lee side showers, and we've got the opposite because the lakes are so cool. We've got clear conditions over the lakes and then kind of a good weather lee side effect on the southern shores. There's our surface chart at this hour. We can see the extensive moisture out ahead of the front. Mid-60s dew points for the most part, but with that westerly flow, that's going to give us kind of a unidirectional wind profile, so it's going to be hard to develop helicity. And that'll contain the tornado potential to a large extent. I would expect the main threats to be wind and maybe some small hail. Then out to the west, we've got a new polar front coming together. In fact, I would probably call that a occluded front. And there it is in North Dakota, and really what the key is, again, is the moisture. And I can see mid-60s dew points all the way up to the front, near Sioux Falls, and then up to the north, some very good moisture, upper 60s dew points in North Dakota, so this could be a good environment for some storms. In the northwestern U.S., kind of a quiet day. In Montana, Idaho, and the northwestern states, it's mostly under the influence of this large high-pressure area. It's part of the Pacific High out over the oceans off the coast of Victoria Island. And embedded in that, we've got this weak little system. It's probably kind of a weak heat low there, centered on the Spokane area. But we do have a lot of cloud material shown on the satellite, and this is indicative of kind of a deep trough, probably along the coastal area, and that's given us kind of a jet stream axis across northern Nevada into Montana. So embedded in that, there's probably going to be some shortwave disturbances, and that's likely what's creating some of the cloud material you see there in the Pendleton area. And then in the southwestern U.S., it looks to me like they're getting a handle on those fires. Not as much haze and smoke in the San Joaquin Valley. Otherwise, it's fair across the southwestern U.S. I can see the rotation of the upper level high running about like that, so I think we got a Four Corners high established right about there. And I would say that probably extends down into Arizona due to that northeast component, and we're probably seeing a circulation kind of like that. So that's probably keeping the monsoon pattern shut down a little bit. And there's the chart in the southwestern U.S., leading edge of that little Pacific front, coming into the Winnemucca and Salt Lake City area. It is a dry front for the most part, but I do see some 50s dew points up to the north, so I wouldn't be surprised to see a few showers in the mountains. Down to the south, heat lows, one up there in Utah, another around Ajo, Arizona, and those temperatures coming up to 100 at Phoenix and in the Salton Sea area. And then Texas, where we've got the northeasterly component in place, that's going to keep the dry line shut down. So as a result, we see not much moisture gradient across West Texas, just dropping very gradually from mid-60s around Waco to 50s around El Paso. Here's a look at the high-resolution rapid refresh, looking along that front. And keep in mind the front is somewhere, I'll probably put it kind of right in there. It looks like maybe a small mesolow in western Vermont, and then connecting back up kind of like that right there. So that's kind of what I'm seeing. The dew point field showing the best moisture down to the south. Those are going to be 70s dew points. And then when you get north of Pennsylvania, you're talking mostly 60s dew points. The model not looking for much organization of these cells. You can see they're just kind of remaining scattered there. Looks like the most organized activity probably in the State College area right there in west central Pennsylvania. Let's check out his sounding, proximity sounding. We'll just kind of drop that ahead of the storm and look at the environment. Well, what do we see here? About 2,000, 3,000 feet of moisture depth. So there's not a whole lot of capping. So we'll kind of see clusters go up here and there. And then the photograph, that's indicating that we do have a well-sheared environment. Now there is some 0 through 1 kilometer shear. You can see that right there. The problem is that this does not form a good hook shape. And as a result, we don't really sweep out much SRH. So that's keeping the values, where are they? Yeah, down below 100. You know, you could always get an accidental supercell in there, a little bit of rotation, where things just really come together, but it's very hard to predict that. Generally, that's the reason you're looking for mesolows, because it helps concentrate enhanced SRH like that. And then a quick proximity sounding around Bennington, Vermont, down to the south. Looks like a little Cape robber up there above 14,000 feet. That's going to keep the capes on the low side, so down below 1,500. There is this very strong area of instability in the mid-levels. 850 up to 700 millibars. However, it is shallow, so I guess that's going to make for some shallow convection. Now we do have 0 through 1 kilometer shear, but the same problem. There's not much curvature in that hodograph. So things are going to be dominated mostly by the bulk shears. You're going to get some modest development of cells, and the main threat will be wind. And you can see the decapes. Where are those decapes? Yeah, even that's not too high. That's only about 770. Let me poke around and see what the decapes are running. 800. I mean, that's elevated, but it's not particularly high. So I would expect just a few strong storms here and there, and not much more than that. Well, there's 1,000 right there. I guess that was around Boston. Anyway, let's move on. Okay, it looks like the models came in about 140. Yeah, there's all the GFS fields there, so let's head on over to the Tropical Atlantic site and plot that up. Okay, so these model plots are only 10 minutes old, fresh off the CPU at INSEP. Let's see what we got here. We got to untangle this. I'm going to start out with the TVs. Those are the consensus. Let me find that. Yeah, the TV products, those are super ensembles, and you can see they've got that pretty much going right into the Beaumont-Port Arthur area. The official forecast, let me just overlay that. Yeah, there's the red, the official forecast. Then the deterministic GFS, pretty much right in there with those TV tracks. Some of the models going west are the Canadian model. Got that flashing right there. The interpolated HMON, Hurricane Mesoscale Non-Hydrostatic Model. Got that flashing right there. And looks like the UK model has pulled a little bit east instead of west. So yeah, looks good to me. I guess Beaumont-Port Arthur is it, unless there's a change in the base data that affects the models at 0Z. So we'll see what happens this evening. Okay, that's about all I've got for this evening. Thank you for watching Forecast Lab. And just a quick shout out to Michael R. Thank you for the increased Patreon pledge. We'll be back tomorrow and cover more of Laura, so please join us. Take care, and we will see you tomorrow. Bye-bye.